Hello everyone, I hope you all are doing well. This side Priya Bhatia. And in this specific video, we will going to discuss about another interesting, you can say, model evaluation technique, which is very widely used for the classification part per se. I know you all remember that, when we were discussing about the classification algorithms, we have already had a great discussion about different classification evaluation metrics, right? We have talked about confusion metrics, we have talked about accuracy, we have talked about recall, we have talked about F1 score. There are so many different metrics that we have covered up when we are talking about the classification problems, and we have seen the scenarios as well where at what point of time which particular classification metric is pretty much important. For example, when we will be having imbalanced data, I always uh, told you that accuracy is not a good measure in that scenario. Maybe we can think of precision, recall, or F1 score in that case, depending upon what kind of problem you are solving. So, apart from whatever discussions we have made so far, this today's discussion plays a very important role when you are doing your projects in the industry or whenever you are doing your own research. I remember when I was doing a research of, healthcare domain in my IIT days. So at that point of time, this AUC-ROC score, which is what we will discuss today, plays a very pivotal role in order to get the results. So people usually or researchers usually rely on these AUC ROC curve a lot. So today we will try to see that what is this all about. Please try to document your learning of this session. Specifically, I am saying because this session is one of the most important session, and till so far in my course I have not covered up this specific topic in detail because I was waiting for this specific video where I'll dedicatedly talk about this AUC ROC curve. It might be a long video, I'm not sure, but please try to document it, whatever things I'm trying to convey in this video. And if you are having any sort of doubts in between, please do reach out to me and try to resolve it. Or maybe you can do your own self study and do your own research, maybe via using chat gpt platform, Geeks4Geeks website, and try to resolve your concerns as soon as possible. So now let's deep dive into this AUC-ROC curve, and let's try to understand first of all what is this curve all about, and we will try to see everything in detail with the help of one simple example. Okay? So let me write it down: AUC-ROC curve. Okay. So let's try to focus over here. What I will do is I'll try to take a few values which I will also use in my code implementation. So this is, let's say, data points that we have. So let's assume that it's a classification problem, and we have been provided weights of certain people, and depending upon those weights we need to have a target value which is obese, which indicates that whether a person is having obese or not. When we are saying 0, it means that that person will not categorize as obese. When the value is 1, it means that that person will be categorized as a obese. So 0 and 1, so kind of a classification task. We can clearly look upon that, right? It's a classification task, right? So let's try to now focus on how basically these things works when we try to plot these values. So let's assume that we will be having x and y axis available with us, and let's assume we want to apply logistic regression algorithm to get that predictions done, where this is something which is a target value, right? Now whenever we are applying the classification algorithm, for example logistic regression, you know that there is a sigmoid function which works internally and whose major purpose is to convert that values which we are getting in the form of a probabilities. I hope that you remember that session where we have covered up logistic regression maths in detail, right? So let's assume that in the x-axis we have weights available with us, and in the y-axis we have the target values available with us, which is nothing but whether a person is obese or not, whether a person will be obese or not. So now in this case, we have weight value as 50, let's say 55, let's say 60, let's say 65, let's say 70, let's say 85, let's say 90, and then finally we have 100. Finally, we have 100. Now, I hope it is visible, right? This is 100. So this is the complete, you can say, altogether values that we have in the range from 50 to 100. In the y-axis, we have the target value available, which will be minimum as 0, maximum as 1. As we are trying to plot a sigmoid function, it looks like this, where in between somehow you all know that by default there is a threshold which is being set, and it is nothing but 0.5. Might be when I'm plotting, it is not looking apt, but I hope that these things I have already showcased you in my previous discussions of logistic regression, that whenever we will apply these kind of algorithms, there is a sigmoid function which works internally, right? Sigmoid function which works internally. And the main purpose of this sigmoid function is to simply return the probabilities. So it will try to give the probabilities of giving the answer as 0 or 1. So what is happening here? For example, we are saying if the weight is 50, the person belongs to known obese category, means it belongs to class 0, means the value of the, or the probability should be less than 0.5, then only we can say it will belong to class 0. Then if the weight is 55, again 0. If the weight is 60, again 0. If the weight is 65, it is showcasing as 1, means it belongs to somehow obese category. Then you can say for 70, it is again 0. 85, it is again 1. 90, it is again 1. 100, it is again 1. So what is happening? When you are applying a model, right? Your model, when I'm saying model, I'm talking about here specifically as an example, logistic regression model. By the way, I will showcase you the implementation of whatever things I'm talking about here. Logistic regression model, let's say we have trained on top of this data. Now, when we are getting the predictions, we will be able to get the probability, right? We will be able to get the probabilities. Probabilities of belonging to class 0 means whether the person is not obese, and the probability of belonging to class 1 indicating that person belongs to obese category. Now, what is happening here, that we will be having the probabilities available. Probabilities as per that on the basis of threshold 0.5. If the value is less than that, it will categorize it as 0. If it is more than that, it will be categorized it as 1. I hope you all are aware about this part, right? Now, because the threshold is 0.5, this is the threshold value which is by default 0.5. We are getting the answer in the form of zeros and ones. Firstly, we will get the probabilities followed by the clear-cut answer as per the threshold value 0 or 1. If I'll change this threshold value, definitely I hope you all will agree with me that the complete evaluation of getting the value as 0 and 1 will get changed. For example, if I'll change the threshold to maybe 0.8, and if I'll say that if the value is more than 0.8, give the answer as 1. If it is less than 0.8, give the answer as 0. Or if I'll just decrease it down to 0.2, again completely the evaluation values will get changed as per the given threshold. So threshold plays a very important role. And with this threshold playing of that different numbers, we are trying to curate something called as AUC-ROC curve, which is our today's discussion. So whenever we're talking about this AUC-ROC curve, first of all, this is a curve made up of two important components. First component is in the x-axis you will be having FPR. The full form is false positive rate. And in the y-axis you will be having TPR, called as true positive rate. So here, if you will be able to observe, we will be having a value of TPR, we will be having a value of FPR in the x and the y-axis. Now what will happen is, we know by default the threshold is 0.5, and when the value of threshold is 0.5, what is the value of TPR and FPR we are getting? We will try to change these values and we will try to mark those numbers. But before jumping towards that part, let me try to explain you what is this TPR and FPR, although I think you already knew that fact as well. But still, let's try to understand that. I hope you all remember the concept of confusion matrix that we have covered up. Confusion matrix. So what we have observed there, if let's say we will be having the predicted class as 0 and 1, and the actual class as again 0 and 1. So this belongs to actual class and this belongs to predicted class, let's assume. So in this case, if let's say your actual value is 0, means data actually is not obese, and prediction is also saying 0, it means it is nothing but true negative. Similarly, if let's say actually you are saying that your data belongs to obese class, and your model of logistic regression says yes, that yes, it is a obese class, so can we say it's a true positive case? Now, other two cases are nothing but you can say it's a false negative case and it's a false positive case. How I'm writing it? The prediction says the value is 0. The prediction says the value is 0 means it belongs to negative class, but it's a false negative class. Why? Because the actual is 1, but the predicted is 0. And similarly, in this case, you can say actual is 0, predicted is 1, so it belongs to false positive case. Now, in this specific scenario, if I'll ask you what is the meaning of TPR and FPR, true positive rate. So, true positive rate indicates that how many of them are true positive out of total positive values. So, again, I'm repeating, out of total positive values actually that we have, which is the summation of TP plus F1, Fn, this is the evaluation of TPR. So what is TPR? What is true positive rate? It is nothing but is the ratio of how many of them are genuinely actually true positive predictions out of total actual values which are true in nature, right? Which are actually obese. So this is the meaning of TPR. So when I'm saying TPR in the y-axis, so we need to evaluate the value of TP divided by TP plus the value of Fn. So that is the evaluation of TPR, true positive rate. We have to evaluate on the x-axis the value of FPR. What is the meaning of FPR? FPR is nothing but the false positive value. How many of them are false positive out of actual, negatives value that we have, which is nothing but this is the portion I'm talking about. So if I want to evaluate what is the value of FPR, false positive rate, it is nothing but false positive divided by false positive plus true negative. False positive plus true negative. So that is the meaning of false positive rate. So we have the values of TPR, we have the values of FPR. So this is how basically we will evaluate the value of false positive rate, which is false positive divided by the value of false positive plus true negative. Make sense? False positive plus true negative. So now what will happen? It's quite interesting now. So what you will do is you will try to plot as per the threshold values what is the value of TPR and what is the value of FPR. If let's say the threshold is 0.5, what is the value you are getting? If let's say your threshold is 0.8, what is the value you are getting? The threshold is 0.2, what is the value you are getting? See, whenever the threshold will get changed, I hope you all agrees with me that these four values, true negative value, false negative value, TP value, FP value will get changed. And if these values will get changed, your value of TPR and FPR will also get changed. So if you will be able to observe here, in our today's code implementation, I will be working with 4 specific thresholds. These are, let's say we are working with 0.2, 0.4, 0.5 and 0.6. And then we will try to see that in each and every threshold, when I'm saying threshold is 0.2, it means that if any probability is more than 0.2, it belongs to class 1. Less than 0.2, it belongs to class 0. For 0.4, same thing will happen. For 0.5, same thing will happen. For 0.6, same thing will happen. You want to add at 0.8 as well at your end. It's your wish. Now, the thing is, in every changing threshold value, your value of confusion matrix will get changed. And let's try to copy those things, that what is the value you will be able to get. Let me do one more thing. Let me try to add here 0.8 as well. So let's try to go for 0.8 as well. And let me just connect this file and let me run this code. so that we will be able to get the confusion metrics of all of those thresholds, and I can showcase you that how the things are working to get that plot work and what is the real inference of that same plot, right? So it is connecting and it is connected now. Let me run this code. I'll explain you each and every stuff with respect to code part as well. So please wait for a moment for that aspect. But before that, let's try to build a understanding towards this part. So I'm just copying it down and I'm just pasting over my notepad. So let's try to do one thing. Let's try to paste over here. So we are working with different set of thresholds, and you can see it's a complete flow chart where somehow okay, we are getting here these values. So let me do one thing. Let me start from above part, and then I think if I'll just take it down, we will be able to have all the values. So yep, this is how our values looks like. Okay. So here you can see one thing. Here you can note one thing is there, which is that with respect to every different threshold, our confusion matrix varies. I hope you have observed this part, right? With respect to every specific threshold, we have a different confusion matrix. Now let's try to understand this confusion matrix. You can see it is a number which is TP, true positive. You remember our confusion matrix I have mentioned above as well. This is a number which is true negative. So if you are saying 3, 1, 0, 4, 3 indicates true negative, 4 indicates true positive. Let me write it down here so that it will look much better. Then 1 indicates here false positive and 0 indicates here false negative, right? So we have the value of true negative. We have the value here as false positive. So I'm just referring this part. True positive is 4, false positive is 1, true negative is 3, false negative is 0. So by default, I believe the configuration will be in that case will be, it will be 0, it will be 1, and it will be 0, it will be 1. So it means that they have just made it reverse in their original configuration. This is the predicted class and this is the actual class. That is why we are getting this kind of results. I hope this makes sense to everyone, because that is the only reason we are calling it as false positive in the second place and false negative in the third place, right? So this is how basically the confusion matrix configuration looks like, where on the row wise we will be having prediction, and on the column wise we will be having the actual values available. Okay, makes sense. Now here you can see that because these values are varying, threshold is 0.20, it means that any value, any probability which is less than 0.20, the answer will belongs to 0 category. More than 0.20 or equal to, it belongs to class 1 category. So what is happening is, in this specific scenario, we can clearly see that with respect to that values, we are getting four values: TP, FP, T and Fn. And then we will try to evaluate with the given formula what is the value of TPR and FPR. And we got that value as 1, 0.25. So now what this AUC-ROC curve will do? Let's try to understand that. Can you see this curve? So now if I'll just try to copy this part as well and explain you what is the intuition behind the same. Let me just copy over here and let me just paste it over again, scribbling. So let's try to now focus over here. So can you see that we will be having in the very first part, when the threshold is 0.20, the value as TPR is 1, TPR is 1 and FPR is 0.25. FPR is 0.25. So where is TPR as 1? Where is TPR as 1? This is the value. FPR is 0.25. This is 1 and this is 0.25. So this is the point where I think we are saying the answer will be, or the threshold will be, we are considering it as 0.20, right? 0.20. Similarly, what will happen when threshold will get changed to 0.40? What is the value of TPR and FPR? TPR is 0.75 and FPR is 0.25. So it means that this is the point that we are getting where the threshold is 0.40. So what is happening is, at every moment when we are changing the threshold, we are trying to plot these points, okay? Similarly, you can see threshold 0.50. What is the value of TPR and FPR? Again, the values will get changed. confusion matrix values, your value of TPR and FPR will get changed. And you can see the value comes out to be TPR value is 0.75, FPR value is 0.25. So I feel this is the value for 0.50 if I'm not wrong. So this 0.40 belongs to 0.75. Okay. So both of the thresholds 0.45 and 0.50 lies on the same header, because both of them are having a same value of TPR and FPR, which is 0.75 and 0.25. For 0.60, we have a value as 0.75 and 0. So 0.75 and 0 means this is the value we are talking about, where the threshold value is 0.60. 0.60. Similarly, if you will be able to plot for 0.80, again 0.80 belongs to this headline itself. So in this way, you will try to keep on changing the threshold values, and you will try to plot the values. So what you are observing is that if you will try to combine all of these plots all together, like this, like this, like this. So this line which you are seeing in the diagonal line, this is the line which indicates that this is the point where TPR and FPR values are exactly equal to each other. But after that, remaining thresholds, we're trying to plot those dots, and then we're trying to combine all of these values all together to make a plot all together. So what is happening is, if you will try to see this area, this specific area, which you can see in this graph, this is what we will try to evaluate. The volume of this area we'll try to evaluate. And this is something which we are calling it as a AUC, which you can see here. AUC is 0.94, means 94%. Usually what happens is that higher is the value of AUC, we are saying that we are having a better model to make the predictions. That's the core idea. But let's try to make it more intuitive. Let's try to understand that what will happen when we are somehow decreasing the threshold, and what will happen when we are somehow increasing the threshold, right? So in this case, if you will be able to see, as soon as you are trying to decrease the threshold, one trend you will observe, and this is important to understand. When you will try to decrease the threshold, what will happen in that case means you are trying to, in a flow chart, you are saying that let's suppose my threshold is 0.2. Okay. So in that case, somehow you are saying this is my line, means you are somehow comfortable in predicting the obese class. So in this part, when your threshold is lower down, you will definitely correctly classify all the people who belongs to obese category, right? Because the value belonging to 1 will be more, because you are saying that at any point of time when the probability is more than 0.2, the answer will be 1. So definitely you will be having more data points, results which belongs to 1 class. So definitely those points which are having obese category will fall into that place. So in other words, when you are trying to lower down the threshold value, when you are trying to lower down the threshold value, so you are somehow trying to reduce the false negative, and you are trying to increase the false positive. And this is usually happened specifically in those instances when we are dealing with some healthcare problem. Do you remember the case of precision and recall? I told you in the recall, our purpose is to somehow reduce the false negative, and that is why this is also preferable to go for healthcare domain. Same thing I'm saying today also. What I'm saying is that, for example, a person is suffering from cancer problem. So what I want is, false negative meaning is that a person is actually not suffering from, the prediction is saying that it is not suffering from cancer, but actually the actual target class says that it belongs to cancer problem. So what is the issue here? Let's assume patient genuinely is having a cancerous issue, but doctors, after seeing the reports, says via the machines, AI-based machine says that, that person is not having a cancer problem. That is a major issue, because that risks the life of that particular person, right? So that is where we have to reduce that chance. And at any point of time, if you want to reduce that chance, for example, in this case, when you reduce the threshold to 0.2, the chance of incorrectly classifying a person as obese, even though he is obese, is very, very low. That is where the main purpose of lowering the threshold will come into picture. And when you increase the threshold from zero point 0.5 to zero point 0.8, things will be vice versa. Means you are somehow increasing the false positive and sorry, increasing the false negative, and reducing the false positive values. That is something you can call it as a spam classification problem. You can think about it just like a precision scenario. So always remember, this is one of the very widely asked interview question as well, that what will happen when we decrease the threshold? What is the impact it will have? So definitely it will try to decrease the false negative values and increase the false positive rate, and vice versa will be if you will increase the threshold, right? That's the overall idea, that's the main picture. So what usually happens is, depending upon what kind of problem we are dealing with, we try to change this threshold value, and as per that change of threshold value, we will try to get the results more appropriately by looking into the trade-off of false positive versus false negative. That's the whole idea, that's the whole thing. And depending upon, while doing the model creation, what is the value of AUC, we can basically interpret our model that whether it is behaving in a more apt manner or not. Because AUC-ROC curve basically deals with all the threshold values. It basically tries to check all the permutations and combinations, and then it will try to curate a complete curve altogether. I hope it makes sense and it's not that much heavy session. With the help of example, I try to showcase you everything with the weight and obese part, and I hope now it is clear to everyone. So now what we can do, I'll try to showcase you the code part. Same thing I have done here. I have taken the same example with the help of which I have explained you the concept. This is the target value. I have applied a model, fitted that model on weights and obese. Predictions we will be able to get. Now what we are doing is we are trying to apply that predictions as per the threshold value. If the value is more than or equal to that threshold, we are calling it as 1, otherwise 0. So we are converting that value in the integer form, whether it's 0 or 1. Finally, we will be having confusion matrix available. How the confusion matrix by default looks like in this function, I have already explained you, right? This is the predicted, this is the actual in this function, which we are using here. Now we are trying to get the confusion matrix. We are printing that. That's why we are getting the confusion matrix in the output as well. And then we're trying to split that value. This revel function basically tries to flatten your two-dimensional array into 1D part to create 4 values, TP, FP, FN, and TP. We are trying to get that values. After that, we're trying to evaluate the value of TPR and FPR for all the instances. Now, you know what is TPR? TP upon TP plus FN. What is FPR? FP upon FP plus TN. So we are trying to evaluate that up to 2 precision decimal places, and then we are playing with the threshold. Whatever values we're getting as per the thresholds, we are trying to curate a ROC curve for that. And finally, we are getting the AUC score by applying this ROC AUC curve with the obese and probability values that we're getting. Then we're trying to plot those values, doing a labeling part, and finally printing each and everything with respect to every threshold, which we are passing down in the list. If you want, at your end, I'll share you the code file. You can increase this threshold value, check it out, what is the value of TPR and FPR we're getting and how it is being changing. You can evaluate that stuff. So this is the complete curve we are getting. Value of AUC we're getting as 0.94, means 94%. And for every threshold, if you can see, because it's a for loop we are applying, and the same thing will happen for all the threshold values that we have. So you can see threshold is available, confusion matrix is available, and then we are applying a revel function because of which we are getting the value of TP, FP, TN, and FN. Finally, we are trying to apply a formula of TPR and FPR, and we will be able to get that value as well. So in this way, we will be able to evaluate for all the different thresholds, what is the value of TPR, what is the value of FPR, what is the value of true positive, true negative, and false negative. So this is the overall idea behind ROC AUC curve. This is one of the most important video. I'm again saying, I hope that whatever points I want to convey to this specific part is pretty much clear to everyone. I have tried my level best to take a simplest example so that I will be able to convey to you in a more appropriate manner about the mathematics behind ROC AUC curve, because I have seen many people in the interviews while doing the project's implementation are really confused about this part, this specific topic. So I hope that now it makes more sense to you all. If there is any confusion, try to rewatch the video again. You have that access, right? And still, if you have any doubts, do your research, exploration, relate with some other examples. Or if you are in an industry, try to see whatever work you have done, try to plot ROC AUC curve on top of that if you're doing a classification task. And with this, let's end today's video. I'll see you all very soon in the upcoming video, where we will discuss some other specialized machine learning techniques in this specific module.